have a very special show. So Aram, thank you for joining us. Before we dive into your background, let's introduce a couple of the special guests from the NVIDIA team who also can enlighten us on your workflow. And I think specifically Craig. Craig, you've worked with Predator Cycling for a while, so you're super familiar with what they're doing and how they're leveraging Omniverse. So, Craig, why don't you introduce yourself, and then Adam, and then we'll go to the star of the show, Aram.
Thanks, Edmar. Yeah, Craig Barr. I am with the technical marketing team on the pro visualization side at NVIDIA. And yes, I've had the privilege of working with the amazing folks over at Predator Cycling. And the great thing about working together with these guys is it tells the Omniverse story in a very simple way. Working with a team like Predator Cycling, it makes it very easy because they knew what they needed, they knew what they wanted, and they had a lot of challenges that they weren't able to achieve these type of visualization goals and this type of way of working with complex data. And Omniverse was able to provide what they needed to do. So the great thing with working with people that know design and they know what they need to build quickly and be able to produce, and at the end of the day, get that product to users. And they're all, the nice thing about Predator is all the users of their product, their bikes, are ultra high-end users there. And so everything about Predator really talks about precision and accuracy and engineering. It's an amazing design story. So working with them has been nothing more than smooth and fun, actually. So, the cool thing with working with Aram and his team there is that we were able to produce some pretty cool renders that they had already had going, and we were able to kind of build this nice, very simple to tell story because it tells the story of how cool their design is and how cool Omniverse is to help them along their way there.
That is a great introduction to this. So thank you. Really looking forward to the back and forth we have in a few minutes. And Adam, you are relatively new to the Omniverse team. So tell us who you are. What are you doing here?
Yeah, totally. So new to the Omniverse team, but not so new to Omniverse, right? My past jobs were a lot with CAD, right? And so I come from that CAD background. I pride myself at being a good clicker, which for those of you who are good clickers too, like video gamers or software users or other software users, you'll be a quick learner for Omniverse. So that's my kind of motivation to get you clicking more, I suppose. I'm on the simulation technology team at Omniverse at NVIDIA, and I think the coolest enhancement or the newest feature, I suppose, that I enjoy working with the most is the CAD converter for Omniverse. So if you haven't looked into that, I would definitely say look into that too. Reuse your CAD files in Omniverse, open them up, import them. Super easy, very friendly. Great new enhancement. The other thing that I do is I teach at USC. It's something I really enjoy doing. Get to change the way these young students think, and I get to throw an NVIDIA plug in there every once in a while. So go Omniverse.
Awesome. Thank you so much. Really great to have you. Yeah, and totally right. Well, we were actually chatting a lot with Adam before he was even on the Omniverse team. Really great member of the community and super helpful. So really glad to have you both on the team and in this live stream. So Aram, so we've mentioned Predator Cycling a few times. We haven't gone into deep detail on what it is. So why don't you introduce yourself and tell us what Predator Cycling, and then we'll dive in. It's a really amazing story.
Yeah. Well, thanks for having me here. This is pretty awesome. My name is Aram Goganian, and I am one of the founders of Predator Cycling. We started the company itself was formed in 2005, but I started manufacturing bicycles in like 99. It's kind of when the first version of it came about. We originally just were basically trying to make race bikes, so race specific, sometimes even event specific bikes, primarily time trial bikes, built around the rider, just all about optimizing efficiency, power transfer, handling, aerodynamics, everything we could push to win a bike race. That was it. And then that kind of just turned into making more bicycles, making more components, and our goal changed a little bit. but like not really, I guess. It's all about efficiency. So it's all about making the rider more efficient on the bike. So we make bicycles, forks, seat posts, handlebar systems, cockpits, bearing mounting systems for the bottom brackets, cleat adjustments, aligners, so that we can try and get your biomechanics working better and more efficiently. So today, we manufacture everything here in just outside of Nashville, Tennessee. We do additive manufacturing, so we do direct-to-consumer 3D printed products, as well as some hybrid manufacturing. So it's 3D printed and then fused with carbon fiber to make fully custom parts that are designed specifically for an individual rider. And then we also do a more traditional composite expanding mandrel type system, which is how the bike behind me, the RF20, is made. Um, yeah, it's a little bit.
That's wild. And you told me something I thought was shocking the other day about how many parts do you guys actually work on in this kind of context? Like on the bike, how many parts does the bike have?
Oh, well, so the RF20, I mean, Craig knows this. It's a lot of parts. I'm a little obsessed about modeling. So we simulate everything. So all of our stuff goes through simulation. So when we build a bike, we actually build the entire bike. So we do all the bearings, ball races, seals to the bearings. Everything is threaded. If you look at the chain on any of our renders, all of the outer plates, inner plates, pins are all modeled. So it's Craig can correct. I think the actual rendered file that we did for this was about 6,000 or 7,000 components. Because we
gosh.
have
Amazing.
I mean, if you look at some of the models, like the wheels, I actually spoke the wheels. Like it's actually a spoked wheel. So there's actually a spoke and a nipple and the end, and the internal nipple end is on there, and the tires and the belts. And anyway,
I think it was around 7,100 components there, I think.
Yeah. So it's a big
Simply
file.
Amazing. So there are a few really amazing things you just said. The other thing, which hasn't been said actually, is that your team is relatively small, and you're able to do a pretty significant job here with your cycling company. Can you tell us a little bit about like how big your company is? How many hundreds of people are working at this operation?
So we are the actual internal team at Predator is a team of 2. It is myself and my wife that run the show. So I do all of the design engineering work, attempt to do the visualization work. Yeah, that's all on my end. Courtney runs almost 90% of the layups are all done by her. And then she runs the actual business too. That's her.
Yeah, I mean, to me, that's one of the most inspiring things about this, is that small teams of people can actually accomplish this work. So before we get into the kind of the Omniverse part of it, can you tell us a little bit about like what software you had used previously, and then we'll talk a little bit maybe how Omniverse could have helped with some of those workflow problems?
Yeah, for sure. So we use we use a lot of softwares. I mean, our main back end of our modeling is Fusion. We use Fusion 360. We also use Rhino. Those are kind of our two. We're definitely heavy on the Fusion side, because we also, I mean, just a little bit of tidbit. So like we actually design and manufacture all our tooling in house. So we CNC manufacture all of our molds, all our internal parts are all tooled and dyed here. All of our prepregs are cut here, and we actually also build our own machines. So we have massive part files for all of our machines, equipment, everything. So we do that in Fusion so that we can do all the CAM and some basic simulation stuff within Fusion really quick. The direct modeling stuff is done in Rhino if we need it. Anyways, but there's that. Simulation we've done in the past. We've done a lot with ANSYS, and we've been playing around with some other simulation softwares as well for composite CFD analysis. And then for visualization, we're using a lot of Keyshot. And then we also get a lot of files in. So we're getting a lot of SolidWorks files. We're getting a lot of just step files that are coming in from vendors if they give us a model. Yeah, a lot of different things. And then obviously we're like Photoshop, Illustrator, things like that.
Right. And then, so how did you go about discovering Omniverse? What kind of problems were you having that Omniverse was helping to fix?
Well, it's so funny. We were one of the early testers for the RTX A6000. And during that process, we were introduced to Omniverse. And to be honest, when I first heard it, I was like, I don't get it. Like, I don't what is on, like, I didn't understand what it was at all. Like, I got the beta access, I downloaded it, I kind of I was like, I still don't know how to use it. I don't really know what it's gonna do. I get it had connectors, but I don't know. It took me a minute to get it, and then it took me a minute to understand like USD and like how USD, because I come from CAD, I'm bodies, component surfaces, like, I don't know, that's the way I think about it. And then USDs were just kind of throwing it all out of whack for me. But once I kind of got a hang of it, the big thing for us was like our files are big. We have a lot of components and a lot of parts, and usually what we have to do is we have to break them all up. So we'll have a model that's the assembly for the drivetrain. We'll have another assembly that's the fork system, another that's the frame, another that's the mold. We can't dump all of that into one file. One, we couldn't used to do that in simulation because we didn't have enough GPU memory. Obviously, the A6000 fixed most of that for us. But also most of our modeling software couldn't really handle it, or at least handle it well. So that's really what Omniverse came in. Like, that's where it was like, oh, we could just take the whole thing and dump it in there. And that's what we did. Like, that was the first.
Nice.
And you got this visualization tool. Like, you could see the chain and on the cassette and the assembly and the whole thing put together. And without, I'm not a visualization like I not a great surfacer like for textures and stuff and materials. And it's pretty, I mean, you get pretty good results pretty quick, especially if you have the model fidelity coming in. It's pretty quick to do and do well. And it, the rendering is so fast that it's cool. It was it was really, at first, it was just strictly visualization tool. Like, that's where it shined for us.
Absolutely. Yeah.
A lot of amazement and awe happening in the chat right now from a few of Omniverse users. So very, very impressive. Papa Chuck actually has an interesting question. If you ever use Modulus, and I don't know if so you're laughing. Maybe you have.
Well, because it's like it's yes, I want to. I have not used it. We have a bunch of applications that we're thinking, and so like I have a couple little. I'm going to show you guys a couple very simple workflows that we kind of do now. But then one of our parts that's a pretty cool part that we've been working on that Modulus is probably going to be very useful for. And trying to introduce like synthetic data and stuff to some of our modeling and systems and how we do it and look at it. So yes, we currently know, but it's on my list of things that I want to play with very, very, very badly.
Very cool. So anyone who's watching, we actually have a SDD channel, or synthetic data generation channel, on the Omniverse Discord server. Everyone's invited to come in and chat about that. But let's see what you got. So you're gonna show off some of your workflows here. So Wendy will switch the view once you're ready to share.
Yeah.
And while Aram brings this up, so Craig, you've been working pretty closely with the Predator team for a while now, right?
Okay.
Good there. Yes, we've actually we did a live event together most recently at Autodesk University in the fall. And the great thing about that was we had an actual bike. Correct me if I'm wrong, Aram. I believe it was a concept model there, but it was the beauty of that was the overall engineering, the ingenuity, if you will, and the frame of that still blows my mind, especially when you get Aram describing how that's designed and the variation and the flexibility and the different types of materials. It's fantastic. So anyways, we were together live at an event, and we got to meet a ton of people from all different industries. A lot of people obviously interested in design and what Omniverse could bring to their design, regardless of the space they were in. And I'll just say, I don't know, Aram can probably expand on this. I was kind of blown away how many very serious cyclists were there. It was pretty cool. And then on top of that, what we've also done, we've done a case study piece together that we have available on the Omniverse blog site on NVIDIA.com. You can find a great story on Predator Cycling there. And then I had the privilege of putting together a video around the workflows that Predator utilizes with Omniverse. So I put together a video there that we have available online. I think it might be linked through that blog there as well.
Yes, so I'm gonna. Well, Aaron starts talking a minute ago. I will start posting some of these links in the chat, so people have them. Yeah, there's great overview there. So Aaron, you're sharing your screen, I think
Right.
now.
Is it working? Do you guys, everyone see
Yes.
it? So yeah,
Yes.
this is our RF20 that we have assembled in Omniverse. This is one of the models that we're working with Craig on, and there we go. Okay. So one of the things I think I have the hardest time in CAD with, and when I was talking about visualization, it's really this. It's this chain, this whole chain assembly right here.
Wait, I'm looking at. So I see a person that's in a pose of riding a cycle. Is that
I'm
what everybody else sees?
not that. So I'm sharing the wrong thing. That is my fusion.
I was gonna say, and that looks
I
like
did not
very different from
share.
how usually I ride a bike. So I need to work on my posture.
Okay, change window. Sorry, I didn't realize it was specific to the window and not the screen.
That's okay. Take your
Okay.
time.
Is that
Okay,
we're good?
now we
There we
see.
go. Yes.
There we go. All right. So yeah, this is the RF20. And this is the bike that we had on display that had some new features that we had been working on. But one of the hardest parts that we have in most modeling software is showing off is if you look at this chain and cassette and the rear end of this bike, there's a lot of moving parts. So everyone, let me change that. Let's just I don't know, flip it over to path trace real quick. And you can see the detail that comes out in the chains. Like we model all this out, we model as an assembly, the cassettes, internally all the bearings. You can see how we lace all the spokes. And we do this. One, we do it for simulation reasons so that we can actually simulate parts of these and how some stuff's working, but also so that we get clearances, tolerances, and we can get a cool visualization for the the bikes and show customers so it looks real. This was something that was really difficult to do in most. I mean, we couldn't do it before Omniverse. We didn't do this well at all. So this is a big one. And so the cool thing too is we can change the colors on this. We can set this up so that the customer can see their options. And that's kind of yeah, I mean that's the main this is our first use case for Omniverse, was to bring this in and do it. One of the things that we've been working on doing we're slowly doing it out, but we have a pretty massive part catalog, and so we've now been starting to bring in each of the parts that make up the bike as its own separate asset, so that we can actually start assembling the bikes in Omniverse much quicker. Right now we're doing part of it in Omniverse, part of it in modeling, but the goal is so that we can basically have our frames, we can drop our frame right in as a USD, and then basically connect it with all of the components and drivetrain and assemblies all inside Omniverse. So we can just kind of leverage that. And the cool thing is, so we're using Nucleus Cloud. So we were in the early access for that. And so that's been a super helpful tool. So especially when we're working with like Craig and TJ at NVIDIA, we could share assets super easily. And they could get we're all working on the same data at the same time. So
Very cool. A couple questions coming in as people looking at this and hearing this. One is, can you envision a future where you would insert an actual person's proportions to customize the bike to fit their own body frame? Do you see something like that maybe in the horizon? And then the second part of the question is wear and tear. Are you able to kind of see how different parts might wear out over time using any kind of simulation stuff, or is that not necessary yet?
So yes to both. Yes. So the next part I'm going to show you guys is actually basically that kind of but from so you can fitting a person to a bicycle kind of gets complicated pretty quickly, because you're dealing with not just there's a lot of places where you say, oh, your inseam is this, your height is this, therefore you ride X, Y, and Z. That doesn't really work. We have like knee tracking. How does your knee track? Do you have lower back pains? What's your flexibility? Also, like, what are you trying to achieve as a cyclist? Are you, are you racing the Tour de France, or are you riding to the coffee shop, or are you commuting to school? So it kind of depends. So there's a lot of variables there, but yes, there are tools and thought process on how to basically digitize that process. And that's where we're like thinking like Omniverse could be a massive, I mean, that's how to do it, to basically bring someone in and then be able to fit them, in the metaverse. That's super cool. What we are working on, which let me switch my screen
Very
and I'll
cool. Thank you
show
for those
you.
questions, Leah.
Yeah. So one of the things that we've been working on is our is this. So this is one of our new handlebars. So these handlebars are custom made to a rider. And this is a rider. This is Corey Williams from Legion. So he's a pro cyclist, and we basically use some photogrammetry and then a pretty good size 3D sketch, um, and basically connected the T-spline body to him, and then we can basically load him into Fusion and then um, change hand positions, and basically try to optimize what is the best hand position and what is the best shape of the actual bars. So if you're looking at these shapes of these bars, you can see that they're this very strange shape. And this is actually to help divert the airflow around him and change that um, change how the air is seeing him and close in that frontal cavity. That's what we're attempting to do. And
Wow.
Wow.
driven by simulation. So this is where, anyways, modulus, Omniverse, synthetic data can start becoming super, super interesting. Right now, I have a very simple program that I built into Fusion, a little Python script that basically runs through different variables and repositions that. And then we basically run that data set through CFD, get the results from CFD, make the updates to our program, get new shapes, and then we basically use Omniverse right now for all of the visualization side of it, to actually show the customer, be able to visualize it. But the idea is we could, I think, if I understand modulus correctly and what we can and can't do, but I think we could do this in modulus, and we should be able to change the synthetic, would do it with synthetic data. I think that, anyways, that's the idea. But that's where we're kind of headed. Well, that's what we're currently doing for this product, and we've taken to market. And we've seen it's a pretty ridiculous reduction in drag that we've been able to do from his old position to his new position. And we validated it this year with we did our estimations, and we did some predictions on course predictions, and we were pretty close. And they did a couple other big races, did the Commonwealth Games this year, and some big US races, and did very well, and then did some wind tunnel testing as well to validate all the numbers, so it came out pretty good. So
Oh,
Yeah, the
awesome.
cycling,
Congratulations.
thank
the
you.
cycling industry is so competitive, right? And you have to stay competitive to be relative. And just seeing what you're doing here is a pretty awesome marriage between CAD and synthetic data, these pictures and revolutionary thinking. I think it's really great, man. It's really cool.
Thanks. Yeah, and I think the thing for us is that it's the in cycling we've always tried to collect data. It's always been a big, I mean, it's a data junkie sport, probably why I like it so much. But what now we're trying to do with this idea of like synthetic data, simulation data, predicting what kind of data we're going to get and looking at that data. So like, our basic, one of the things that we look at is like basically a pro cyclist. If you're a top level pro, you go to the wind tunnel 2, maybe 3 times a year to get basic streamlined data. So you can within that make maybe, let's say, 5 positional changes. So you're testing 15 positions per year. Over a 10-year career, which is a very long career, you're only talking about 150 position changes. With Corey, we simulated, I want to say almost 2,000 positions is what we simulated overnight. So, well, I think 3 nights we did it. We broke it up, but yeah. So I mean, we were able to get a lot of data back out and then pull that and optimize his position quite a bit. Sorry.
Very cool. Yeah, and that fits a lot with what we see in our simulation stories is put it into a virtual world where you can run the simulation many times over without the need to have the physical limitations.
Absolutely. That's the beauty. So that's where we're very much trying to head towards quickly. And trying to bridge that gap and try to close the loop so we can get the data as fast as possible and update our models. So that's one of the things we do here. So we actually all the parts that we designed, we actually built our own testing machines here. So we simulate loads and forces on our components, and then we basically built a machine that does the actual loads and forces. And so we have the feedback directly. And we have a kind of a data logging system that we've built. So we can serial number the product, we simulate that product, see what it can do, and then make the product. And we also data log the whole process, and then we actually test against it so we can actually get that closed loop and then update our simulation data and build a more controlled system. So data, it's all data.
Amazing. And you mentioned earlier that you've been using Python yourself. Maddie is a resident Python expert. Have you has your background always been Python, or are you did you kind of start getting into it of late?
To be honest, it's always I've always just learned what I needed to get whatever I wanted done. Is kind of my thing. So all of my programming really started with WordPress, because we wanted a website and we wanted to be able to sell things on it. So it was quickly learning, PHP, CSS, HTML, and just kind of picking it up, figuring it out. And then Python, really we started using Fusion. Python became because we could make our own plugins and stuff for it. And then it's a relative, I'm not great at it, but relatively straightforward. It's, and it's accessible. So, so I started using that and then started building all kinds of small tools and calculators, and it's a great tool to grab for data, to analyze data and stuff, and data sets. It's
Totally.
Very cool. We have a passionate request from the community to please, if you do start work with Modulus, to share your journey on the Discord server so that the community can learn from it, because it seems like you have a growing fan base here, people who are really impressed by how you're leveraging all this technology to stay competitive or just grow your business. Really, really impressive.
I will. I haven't been very active on Discord, but I will start being. I haven't done it, but I will.
Well, I know it sounds like you're very busy, so you can always feel free to come on and give us updates too on a live stream. That would be great to check in with you.
For sure.
Okay, so right now, you're showing us Fusion right now, and then how are you bringing in this stuff in through the Omniverse platform? So you said using Nucleus.
We are using Nucleus. So currently, the way we're doing it is we're exporting everything out as USDZs from Fusion, the individual components, and then we're bringing that into our Nucleus server here at the shop, and then the ones that are assets that we're sharing more, we're putting onto the cloud, Nucleus cloud. Is how we do it, and then we're assembling everything there. Yeah, that's how.
And then, so you mentioned the vendors you work with. Are they using similar software? So you're basically providing these files to them, and they're using that to manufacture.
No, we actually manufacture everything internally. So we do 100% manufacturing.
Wow.
Everything's manufactured here, except, well, I take that back. Okay, there's like 2 stamped parts that we don't manufacture, and then there is 6 aluminum parts that we don't manufacture ourselves.
Out of the 7,000 moving parts.
That's just the component assembly, but yeah, we manufacture everything else is done here, including tooling. We make all our own tooling.
That's amazing.
So we have a lot of parts and some parts that didn't go right that's sitting in the back that I don't have the heart to throw away. So it's there's too many hours that went into that. I can't just go out. It's gotta just, we have to have it. So but yeah, so that's kind of our so we don't send out, so we receive in, and that's been a problem that we've had in the past, is receiving files and either we can't read it or something gets lost in it, but we've been able to pretty successfully bring all of that into Omniverse very effectively, and it hasn't had the penalty that it's had in other platforms, bringing it in and losing a bunch of stuff, or being able to keep it and then be able to take it into something else. And it's been pretty seamless in that respect. So
Just
that's been pretty cool.
curious.
Sure.
Have you been? Is the CAD converter helpful in that category? Have you been using that?
I haven't used it.
Oh, you got
haven't
to. It's
used
gonna change.
I
It's
haven't-
gonna change everything.
I know you talked about like, I was gonna do that, and then I haven't used it. I want to though. I need to.
I'm gonna send you a video.
Yeah.
And it'll show you exactly what you need now.
Okay.
Nice.
Yeah, no, that would be awesome. But on that note, actually, can I ask a question? Since we have
Yeah, of course.
a bunch of Omniverse people. So one of the problems that I've had making the coming from CAD is like joints and assemblies and connectors and like tolerancing. How to in like from CAD, I know how to do it really well.
Mhm.
In Omniverse, I don't always know how to do it very well. And I tend to rely on my CAD data coming in pre-assembled, like for my tolerances, everything very close. Like, what is there like a trick? Is there a tip to like how to do it well in Omniverse?
That's a good question.
So,
Yeah.
because that's one of the things that we do. We do a lot of assembly stuff, and we have lots of systems and things. And so like that's one of the things that's been a little for us has been hard. Well, at least for me, it's been getting it matched up perfectly.
That's actually, yeah, like I'll make a note of that because I know the 2 developers to contact that would have that information for you. So I'll make a note of it and then have them message you.
Sure.
You know, my
yeah,
favorite tolerance tab on anything is just like a global surface tolerance of like 5,000. Bam, go make it. Or 5/10. Hey, make this easy.
Yeah, we do a couple parts that are like H6 press tolerances for bearing inserts and stuff. Those are always fun. But no, I just like that assembly part. I think that for me, coming from CAD, that was like the hardest thing for me to get in Omniverse. That was the one that was tricky for me, is getting that. And then the other one was understanding USD. Like that was I don't know.
Yeah.
Like anything can be in the USD. I don't know. There was like I think 2 months of me just going like, I don't get it. I just don't get it.
You know, when it comes to tolerance stack, there's a lot of statistics behind that, right? Monte Carlo effect.
Sure.
Like there's programs that's dedicated to that. I'm wondering if somehow those could be brought in to USD or something. Not sure, but I'm just thinking off the top of my head.
Yeah. No, I mean, I don't know. Curiosity was that's a big one for us coming for just in manufacturing, and then getting tolerance, getting parts, and then being able to put it in. Like, does it fit? Does it not fit? That kind of stuff. But anyways, yeah, that was one of
There's
the
also
stuff.
something like really prideful and to be very proud about, like, making like your company making all those parts and like at your facility. And I think it's really cool. And I don't think we see a lot of that anymore. And it's something that is like really easily overlooked, like,
Yeah. Well, it's fun too because you learn so much because it's that it's not closed, but it's that very quick data loop. We designed something. I mean, the perfect example, like we designed a part, one of our dropouts we modeled it out. We assembled it all together in Omniverse. Everything looked great. And then we went to do our layup schedule for it. And Courtney comes back to me and it's like, we can't do this. This is going to take 6 hours to do one dropout. It's a non-starter. So we had to go back and redesign it. But like, I think she had come to me at lunch before lunch was like, it doesn't work. So we were able to 3D print a prototype, new mold for it, set it up. And the next morning we were running it. And then I think it was the next day we had the aluminum mold made. And we were off to the races. Because you learn so much because there's always mistakes, there's problems, there's issues that come up. And learning from it is, we got an injection mold. Is it a grip?
Yeah, this is just a little one that I have a little machine at home, and so I cut my own molds too.
Nice.
Nice.
That's awesome.
Yeah. It's a lot of work. It is way more work than you think it is. Anybody of the viewers just thinking about, let's go make some plastic parts ourselves and let's go cut some own, cut some metal. It's like everything's exponential.
I think to your point there, though, Adam, talking about what Aram has as process there. I mean, talk about quality assurance, right? I mean, that's as top notch as you can get, right from design to test, right there.
Yeah, absolutely. That should sing volumes with your customers too. It's almost like a selling point. It should be a part of your pitch deck. You know what I mean?
Right? We should have a pitch deck. That's a good idea.
Omniverse is in there.
Great
NVIDIA is
idea.
in there.
I'll be honest. The last one we moved to Nashville about 5 years ago, and it was really focused on technology. So it was really focused on developing our manufacturing system. You know, because we used to build everything by hand. So it was handmade, shaped, molded. Composite molds. And then we started. You know, about 8-9 years ago, we built a CNC machine. We started building CNC parts. Started making our own moldings. 4-axis hot wire CNC. Started cutting out cores, things like that. And then we realized that it's like, we kind of hit our limit of what we were capable of doing, and you're spending all of your skilled time recreating what you were supposed to create and not developing new things. And so that was what happened with starting to go down this digital like manufacturing path. And since we've been here, we focus so heavily on that and the process, and keeping our data, digital as long as possible, and the process is digital as long as possible, and how we're doing it and getting the data back, that we kind of like forgot about everything else. Like we just been focusing on that whole system. So that there's no deck anything. There's a lot of models and assemblies and stuff, but that's about it. That's something we're trying to tell now, more the story of what we're doing and how we're doing it, and why it's important. Because it is, something in our industry and most industries now, you have an industrial designer someplace, you have a manufacturing engineer someplace else, simulation, and then you have manufacturing, and it's all these separate entities, and in most cases separate companies a lot of times. And there's a lot of information that's lost in between, and tools like Omniverse are connecting that stuff really well, but there's still an amount of data that's just lost in the process when it's not on a single team. When you're on one team doing that, there's just that little feedback, like, if could you get that draft angle like another degree, makes a big difference. So, but yeah,
Some nice feedback in the chat. Papa Chuck has a great quote. He says, "Predator Cycling is like the Mercedes Formula One team for a competitive bicycle."
I like it.
Nice.
I like
That's
it.
free. He's your marketing person.
That's it. Done. Finished. No, it's really good. Thank you. Appreciate it.
The idea is also just stay in the obvious. So what a great example of twinning. Digital twinning is obviously a big part of Omniverse, a big part of the world right now, and trying to find ways to develop smarter. A lot of people probably may not realize that digital twins kind of have always been around, right? Because any product you have probably started somewhere digitally way back when, but now I think the tools are so much more accessible. People can actually do it and do more with it. So this is a real, I mean, you guys take it to like the next level, which is pretty, it's so amazing that you do all this from such a small team as well. Okay, so what are we looking at? We have, I think you're still sharing. Okay, there's.
Yeah, I am. I was just switching back, but one of the things we were talking about on twinning. So so this bike, right, is split into the front triangle, single piece. So it's a monocoque front triangle. And then the stay right here, the seat stays on either side are both, it's asymmetrical, and there's each separate pieces. Each chain stay is a separate piece, and the back dropout's a separate piece. So one of the things that we were able to do, and which is actually Omniverse helped us a ton in, was we ended up keeping the back stays the same on all the bikes. The stays and the whole back half is the same on all the bikes from a mold, but the layups are different. And that's one of the things we used in Omniverse, is actually to size out all of our front triangles so that we could build it within a spec. And so we could make digital, they're digital prototypes. And then I guess it's a twin because we are pulling data back off of it once in testing. But that was a setup that we could do because we couldn't do it before. So that's how we set up all of our size moldings. And as we talk about tooling, sorry, my head jumped there. It took me a minute to move it over, but yeah, so that was a big one for us, and that saved us quite a bit because it allowed us to save probably about 10 or 12 molds that we were otherwise going to have to make. So that was a big savings, and the data coming back in from manufacturing, we can overlay into a lot of this stuff, and that's kind of the stuff we're starting to play with. So on the Python note, we have two machines in our shop that run off of Python controllers. So we have a heated press that runs off of a Python controller and does data analytics. And our testing machine also does as well. So that's the idea that we're going to try and link that now back into Omniverse. Anyways, so
Very cool.
Yeah,
So
Can we connect how much a mold would actually cost? You said you saved 12 molds. What's 12 molds worth to your company? Dollars.
I don't know. It's probably about 3
Time.
weeks. Time. So we measure by time. That's our metric here is time. So every project there is a cost association, but that's for us. We look at it from material cost. What does it cost us and then our cost is time, because that's our fixed. So that's how we kind of look at it. So projects are allocated a dollar amount and then a time budget. So that's how we look at it. But yes, it's a lot. It's 3 weeks, 4 weeks for sure.
A notable savings.
Yeah, for sure. A main triangle mold is typically 2 weeks, is how we kind of associate it. Because it's quite a bit of work. It's 2 full days on the CNC, and then post work, and then tolerancing it, checking it, polishing it. We usually put 2 weeks for both halves. And it's a lot more work than you think it is. It's a lot more work than and then you don't realize how heavy they are.
Oh yeah, how heavy are they? That's a good question.
They're about 260 pounds, a front triangle mold. So
Wow.
it's,
that's
heavy.
That's bigger than I was assuming.
Yeah. So it's a 2-inch thick aluminum mold, and then we water jet cut out the profiles, and then we machine out all the insides. So
Whoa.
But they're still about 260 pounds with all the inserts and everything loaded. So we actually have like this whole system of demolding and pulling it apart and checking them and stuff, so we can pull it apart. But yeah.
So
very cool.
question from Zia is, how many bikes do you make in a year?
So we've typically in the past, before we released the RF20, that's kind of the weird. So prior to releasing these new bikes, we were producing about a little over about 100 frames a year. We were right around there. At that point, we'd done about 1,200 and I think 50 frames we had made. The new bikes, to be honest, our timing was really bad. We launched the RF20. The original visuals of the RF20 were released, I think the week of COVID shutdowns happening.
Yeah.
So the initial release of it, and so that it stopped everything. Everything went on pause, and then the part shortages happened. So we kind of took a pause because we were getting at the point where we had to tell customers it was 8-9 months to get components to build your bike, and that was a non-starter. So we basically decided that in that time we're basically going to focus on R&D. So we're going to focus on development, figure out everything that we were doing bad in our system in production, how the molds are doing, how the programs are running, presses, testing equipment, and just really hone down on all that and just do our engineering work, and get production ready for the bike and all of our components. So we've made a handful of RF20s to date, but we're just now starting to really trying to push them because parts are now available. So our goal on the RF20 is somewhere between 100 and 150 bikes a year. That's the goal for the RF20, and in general production for the bikes. We also produce handlebar systems, so those custom aero bars, as well as road handlebars, track handlebar systems, and then a handful of other small parts and accessories.
That's sweet.
Thanks.
So I noticed the tires on the bike when you were showing. What material are your tires made out of?
The tires, all the bikes that we do are pretty much they're tubeless systems. It's a tubeless tire system.
Yeah.
And then the rims themselves are carbon fiber. Most of them all are carbon fiber. These are just
Very
modeled
cool.
up. Yeah, they're fun. They're these are just a modeled up version of a regularly available wheel. Is how we did it. We don't make our own wheels, so that's something we don't make.
So do you it's a question from Twitch. Do you operate your CNCs too? Because it sounds like you
Yeah,
do everything. No, wow.
I do. I do run the CNCs.
That's got to be
Yeah, I run
fun
the
though.
CNCs. It is. It's fun. I like it. It's like literally our main CNC is like directly behind me, so you can hear it when you're sitting at the desk and you hear the aluminum shooting off the machine. It's fun. It's fun. It's fun to be. I dig it because it's again like I can't tell you how many times we go to make a prototype and we're like cutting the prototype. We're like, oh, why did I do that? Like, why did I put that fillet right there? Like, that was such a bad idea. And so I just go back into the model and I'm like, all right, let's just change it. Like, this is going to take extra 4 pieces to make this mold. I didn't think about it. So now we've actually built a whole bunch of draft analysis angle, like insert pieces, analysis tools that we've built in ourselves to analyze those parts quicker, so we can like, okay, that's like mold checks,
So smart.
like built-in
Yeah.
mold checks. Yeah. And these are
Really
actually
smart.
things that we're
We're
currently
drawing some tangibility there too between programming your CSS from WordPress, your Python. It's like, if you know one of those, you might be able to jump into another one. I don't know. What do you think?
Yeah. I mean, but that's what you need to get it done. I mean, that's the projects. You got to learn all these things to kind of do it. So I'm not like I said, I'm not any sort of like, developer of any kind, but you kind of dabble in everything so you can get it done. So, but yeah.
Well,
and
people are
these are-
asking,
Sure.
Papa Chuck is asking what you don't do.
What do you not do?
Obviously, he doesn't sleep. That's clear.
That's yeah.
I don't sleep much. Yeah. I don't respond to most emails that come in. I'm not an email
That's the
person.
secret.
That's the key.
it.
Yeah.
Damn it, I don't.
You knew
I'm actually
you were doing it
yeah.
wrong.
Well, it's actually super hard for me. Like I'm severely dyslexic, so I have a really hard that takes me way too long to write an email to respond. It's very time consuming. So I don't do most of that stuff. I don't do most of the back and forth with people a lot. I kind of sit in the shop and just make stuff and get things going. Yeah, I don't know. That's yeah. All basically what I talked about is all I do. I don't do anything else.
Well, it's awesome. It's such an amazing story, and again, just really blows me away how and obviously everyone feels the same way. How you're able to accomplish so much as a small team, as a small 2-person team. It's really it's amazing. I like obviously a lot of this wouldn't have been possible not too long ago, right? Like
Yeah.
without these tools and USD as a file format to leverage different tools and apps. I'm really excited about all the different stories and the different companies that are going to be able to exist that weren't able to do this before and be competitive with other companies. I feel like it really is going to open up a lot of different perspectives and niches that we just never got to see before because it was just inaccessible to those developers or creators. So really, I can't thank you enough for sharing the story. You mentioned in the very beginning how when you first came across Omniverse, like because it is such a big thing and a kind of a big kind of concept of what it does. What would you say to people, knowing what you know now? Like, how would you define Omniverse? How would you explain it to somebody if I'm sitting next to you at the next bike race?
Yeah.
You hear I work for another company, and how would you explain Omniverse to me?
I would it is I mean, Omniverse is actually like a metaverse. I mean, it's actually I don't think of Omniverse is a tool, but I kind of think of I don't know, maybe it's kind of weird, but I think of it as a place because I'm actually bringing my parts to come to life. Like this is where they all assemble. It's kind of this maybe playground. I don't know. It's kind of like my
Perfect.
assembly ground. Everything comes together. I build it. There's physics, there's visualization. I can connect into it. I can kind of do whatever I want with it. It's my, it's like my the idea our entire intent is to basically build it into our entire prototyping building grounds to assemble and put everything together, so we can test it and then connect it to the real world. I don't think you can really think of it as like a single tool. I don't know. It's kind of
No,
it's
that's
too big.
fair. That's a
It's not-
great
That's true.
explanation. And as a follow up to that, what would you say your biggest piece of advice would be to people who are just getting started with Omniverse?
I would say start small. Like, don't do what I did and try to do everything. Don't do that. I would say just like grab one of the tutorials. There's a bunch of really good tutorials out there now, especially on you guys have a bunch on YouTube, like some 5-minute, 10, 15-minute ones. I would say get on one of those and just do it and build it and start playing around with it. That's it. I just start playing with it. It's try like I think I don't know. I think
Yeah, it's
Create
great.
is like a good one. I don't know. I think you can do a lot in it, and it's not. It's a little overwhelming at times, but it's not too bad. I would say grab some parts, put it in there, start playing around with it, build it, ask questions. There's lots of users that want to help, and I mean, NVIDIA is. I mean, I don't know. You guys are amazing. You got the amount of support that we've gotten as this tiny little company. Is
It's our
absolutely amazing.
community. It really is.
Yeah, I mean,
I mean,
your success is our
can't
success.
tell you.
What would
Yeah.
you? So, is there any kind of like thing you wish you knew earlier that maybe would help other people too? Like maybe something you discovered that any kind of tip or trick?
Yeah, to be honest, my biggest thing was the USD. Like understanding USD for me was I don't know why, but it was very I couldn't understand what it was. Like I didn't get it. It took me a minute to understand that. And at first, when I first got on, there wasn't as much documentation, video, and coverage, and the community wasn't as big. So it was a little difficult for me to understand the apps and like create and what was it, show the showroom, and then like view, and like I was a little lost there. It took me a little bit to figure out what everything was, and then I struggled with USD. That was my big struggle.
Yeah, I think it's super important to understand that. I totally agree. The NVIDIA has a deep learning institute for anyone watching, where we actually have a free USD course.
Yep.
And Maddie, there's also other stuff happening with USD training, right?
Yeah,
Right.
we've got that's something that we definitely want to do more of is teaching more USD. I know Pixar has mentioned that they have plans to provide more material as well, but we have for sure another USD course for the upcoming GTC, and we'll be putting out more learning material throughout the year.
Awesome.
Yeah, that's my big. If you're starting and you have, I mean, especially if you're coming from like a modeling background, a CAD background, I don't know. For me, it was difficult. Maybe not so much for others, but I, I struggled with like really getting my head around it and understanding how powerful it was. I mean, I still don't probably utilize it to a fraction of what it's capable of, but that I think understanding that because it's really the building blocks of all of it. So that would be my suggestion. And then ask
That's
for
great
help.
advice.
Yeah.
So I just
Awesome.
pasted the advice. I pasted the link for your advice about learning at USD to that free DLI course. So that should be in the chat, at least one of the chats, and I'll do the second one in a second. And then Craig, is there anything? So you've been in the trenches with this brilliant team here, Aram and his partner. So what's your takeaway at the end of the day on this, and where do you think this is heading, and how does impact industries what they're doing?
Well, I think it's worth noting just on that last conversation there, how massive NVIDIA Omniverse truly is. I just want to point out that, the application that we were looking at here that Aram was showing is Omniverse Create. And that is one application of really, I'll use the term infinite because we're always adding more, and there's a lot of experimental things going on behind the scenes. But Omniverse is not just that one application there. As powerful as Create is, Omniverse is this entire thing. So I love that Aram used the big term, the metaverse there, because that really is what it is. It is beyond just not to say it's what we've done here and what the amazing stuff is that Predator is doing is simple by any means, but there's a deep machine learning side to it, simulation side to it, deep real world physics. It goes on, and it's used it's utilized in every single industry out there. So it really is infinite, and there's much more to come. The team that we have at NVIDIA for Omniverse is top notch, and it's big and deep, and there's a lot more to come on that. With what back to your question there, Edmar, on this, and what I think that what Predator has brought here as an example is an amazing case study for how here's a specialized team, a small team, being able to use Omniverse Create in a way that they can visualize their product, organize their data, and very quickly be able to bring a design into production so that they're able to kind of, proof is in the pudding in that virtual sense, in that digital twin sense. I think a couple of the things that I find amazing talking to Aram about his workflow there is, I think Omniverse has really sped things up for them. I think pre-Omniverse, there were times where it was several weeks, maybe even months to be able to get a concept or a visual concept out to a customer or to a potential group of customers there as well. And I think that Omniverse has really accelerated that for them to be able to rapidly swap in components, pieces, design components. That was one of the cool things that we were dealing with there in the middle. Aram's always designing and always tweaking and changing his workflows there. He's laughing, but he knows it's true, because one of the things that we had when we were building up to a live event there at Autodesk University in the fall was that he showcased those really all the work that's gone into the customization of his the new handlebars on there, and we were able to very quickly swap those components and add that to our visualization as to what we were doing there, so that he had a couple different variations in there that he was working with, and he was able to very quickly switch that to his latest concept handlebars, also which he was building live in the physical world there in his shop to bring to the show there at Autodesk University. So a really cool kind of way to rapidly visualize something, work with data in this digital twin sense, and then see it in the real world, in the physical world there as well. So I think the cool thing about this workflow, it's a great example of that kind of, I'll use the term, organic kind of cycle of workflow to this digital to real world. And it's such an infinitely expandable process. We have massive, huge firms and big giant factories utilizing workflows that are actually very similar to what Aram is doing here as well. Maybe a different space, maybe a very similar industry, but it truly is infinite. And I think the future here, and I know that a couple of us that touched on this here, is that it's growing every day. There's the tweaks we're doing, the new things, the new capabilities that we're adding in. Maddie mentioned some of that there as well, that we're adding in a bunch of new things that are going to help people working with complex CAD data going forward as well.
Awesome. Craig, thank you so much for coming today. It's awesome. And Aram, of course, big thank you for really being so open about your whole process and your company. I think it's truly inspiring for many reasons. I think above all, I think that the fact that you're able to do all this is phenomenal. Obviously, you're a very talented person, so it's great to kind of learn your magic, how your magic works. If you have a few minutes, we can jump to the or Discord server. If anyone in the community that's watching wants to come and chat with Aram really quick. Aram, do you have a couple minutes to spare?
Yeah, I got a little bit, and then just one thing I could just add on. Just from like a user perspective, I think for me, one of the big things I was encouraging about Omniverse was just the amount of energy and just power that's coming behind NVIDIA to support Omniverse and everything that's getting developed and at the rate that it's getting developed. I don't know. For me, it's like, it's inspiring because you're just like, oh man, they're doing so much. There's so much new stuff coming out. Like, I got to learn it. I got to use it. And it's not something that's going to just be gone tomorrow. Like, I don't know. It's just like, there's this like long-term stability. Like, this much has been put into it. It's going to be around for a long time. Like, I don't know. For me, it's very encouraging to learn and develop with it and grow. It's just, I don't know. It's a big driving factor for me to put a lot of energy behind Omniverse and, you know, the whole ecosystem of it.
Yeah, that's a great point. Yeah.
Yeah. So, I mean, if
Yeah.
you're thinking of learning Omniverse, you should do it. And if you are using it, you should use it more because it can do a lot and it can do a lot more in the future.
Very cool. It's a great way to close out the show. So thank you so much, Aram. Thank you, Maddie and Craig, of course, the queen of stream, Wendy. Adam, I think, had to leave for another meeting, so thank you, Adam, for coming on. Next week, the same time next week, we have a very special guest also. Slightly different topic. He does machinima based on a Star Wars book called Heir to the Empire. Darth Englis will be with us himself. You'll learn his real name on the stream, which I know, but I'm not going to tell you yet. But he'll be showing off how he uses Omniverse to basically render this beautiful looking Star Wars fan machinima based on a great book. So it'll be really fun to see how his workflow looks. So tune in for that next week. A big thank you to our team, Amelia, who works really hard behind the scenes to help plan these live streams. We have an awesome schedule. Go to our ad event calendar. I'll post it here in a second. You can see all the upcoming live streams. And don't forget to register for GTC early so that you get notified of all the sessions that are important to you.
It's free. Do it. Yeah.
It's free. Thank you, everybody. All right, so if anyone's free, jump on our Discord, discord.gg/NVIDIA Omniverse. Very easy. We'll be in the community voice room, number 1, I believe. You'll see us hanging out there. Community room 1, it's called. And then just a quick correction on my GTC link before, it should be nvidia.com/GTC. That'll bring you right to the GTC page. Thank you all. Thank you, Vincent, for handling the chat. Thank you for all the great viewers out there with the great questions and comments. Papa Chuck's the ideas. You guys are awesome. We will see you next week, but there are more streams coming on later this week from other folks on our team. So tune into those also. Aram, thanks again. We'll
Thank you.
we'll see you in a couple minutes on Discord.
Thanks.
Bye,
See you.
everyone.
Bye, everybody.